Hello, everybody. Thanks for coming to the Nova Software Architecture Roundtable Meetup focused on leveraging AI to advance business processes. My name is Matt Smith. I'm a project manager / business analyst / QA engineer here at Solution Street. We are software development consultants based out of Herndon, Virginia. We work primarily in the private sector, but have had a few public sector projects over the years. We also have a number of open opportunities. If you're looking for a new role, please see our website at solutionstreet.com to inquire. Help yourself to some pizza, some drinks, or just sit back and enjoy the presentation. We'll open it up to questions at the end. Thanks again for coming, and off we go.
Hello, everyone. My name is Sumed Khodke. Nice to meet all of you. Um, I work as an machine learning and AI engineer at Lean Innovation Labs, where we build AI solutions for your data problems. Um, so I'm going to be talking about advancing OCR with LLMs, that's optical character recognition with large language models. Um, so yeah, let's dive in.
Recording in progress.
So Uh, what's OCR? OCR is converting images of text into machine readable format. Um, I'm saying machine readable format because the idea is that we want to extract these fields and then be able to use these extracted fields into your software workflows down the line. Why is it important? It helps in digitization of paper records, not just paper records or any type of records, really. I'm going to be talking about it in these 5 different stages, but really we want to focus right now on the step number 2, that's extracting stuff. And then we'll talk about what are the current methods, conventional methods, traditional OCR techniques, and what are the latest in large language models that we can leverage to actually analyze and reach towards the reasoning phase, towards the understanding phase of these extracted fields. So yeah, what's the core question? How can we use LLMs? Let's see how we do that. Let's first define the problem. What are the different types of optical character recognition? Um, we have basic OCR, which includes text detection or identification. There's text extraction out of it. Then there's intelligent OCR, handwriting recognition, which could include like different types of um, handwriting writing styles. Um, there's layout OCR to be able to uh, parse the document format and be able to divide it into separate subcomponents such that we can specifically look at any subcomponent and extract anything specific we want out of it. And then, of course, there's logo stamp OCR, uh, which is a very well-established area of OCR. People have been using this for uh, almost 50 years now, where you're able to sort of scan something on a shipping label of product and extract information, be able to understand where it's going, where it's coming from, all those things. What are the new frontiers in OCR? They are multimodal OCR and multilingual OCR. We'll look more into this in the upcoming slides. Scene text OCR is to be able to identify text from unstructured kind of image. Now, if I were to compare this with um, text written on a page versus text written on, say, that wall. If I take a picture of that wall, I should be able to identify what's on that poster, on those 3 posters over there. So that's really the gist of scene text OCR. Okay. What are the conventional OCR techniques that are being used right now? Some of the most famous tools, most widely used tools, are Tesseract, which is open source. There's Abby Find Reader, there's AWS TextRact, Google Vision, and Document AI, and different types of cloud API providers that have been providing these conventional OCR models as a service. How do they work? They use different pattern matching algorithms on their backend. Um, the thing about these conventional OCRs is they need a lot of pre-processing as well as a lot of post-processing. Pre-processing could be anything like binarizing the actual image pixels into machine-readable binary data. Uh, you'd oftentimes need to disque the images, meaning you'd need to rotate these pixels into an angle which the models have been trained to identify on. Um, they do have these conventional methods. They do have some strengths. They are really good on clean printed text, meaning they're very good at identifying text written on like a piece of paper or um, like a clean structured format. And they're very well optimized for text identification or detection. Their limitations really come in when you try to have when you try to introduce data drift into your data distribution in your machine learning cycle, where let's say a model was trained to identify text coming from I'm going to use the example of poster again. So it was trained to identify text coming from posters, but right now you're trying to show it a digital image or a handwritten image. So really those are some of the limitations that you are a model that you have selected, you're sort of tied to that specific type of models training data distribution. So if something outside of that distribution comes in to your pipeline, your model may not do very well at it. These are very sensitive to poor image qualities. Uh, your images may give very poor results if they have a lot of noise embedded into the image space, into the pixels. Um, it does not have understanding of context. It may confuse zeros with O's with zeros, and so on. So what do LLMs bring here that we have not had with these conventional techniques? Let's go step by step into what LLMs bring here. First, let's understand what do these vision LLMs and these multimodal LLMs mean. Um, Vision LLMs are LLMs that accept images. They are an extension of the existing LLMs that have been trained on text. Um, they have the exact same architecture with some modifications on their backend, which we'll be talking about shortly. Multimodal LLMs are models that accept different modalities of text. It could be images, text, it could be audio, it could also be videos, because essentially videos are just frames of images, right? With LLMs, you would have a joint understanding. You can interpret all these different modalities in one common latent vector space, and then you can interact with whatever extracted fields that you have. The key, sorry, I just need to enlarge this. Um, we're seeing some of these key abilities that were not previously shown by the conventional methods. We are able to handle low quality images. We are able to identify layouts, which is previously not possible with conventional methods. And then the last point is the most important one. You have a uh, one-step process where you're able to read, interpret, analyze, able to answer all your questions by understanding it within that single step. And also with the advent of these LLMs coming into, with all the advancements that we have with LLMs, we have different ways of interacting with these extracted text fields. So that's an added advantage. Um, Handling low quality images is something that's unique in the sense that if you have a few missing fields within your data, and you are able to give your machine learning workflow, your LLM workflow, the proper context with which that image was given, you're able to fill in those missing fields with the appropriate context. That's pretty much what all LLMs are good at, being able to do a next word token prediction. So LLMs or in general, vision language models are really good at being able to understand the context really well and fill in those missing fields. Okay, let's dive in a little bit deeper into what makes large language models unique in the way that they are. Um, Transformers are the core architecture behind these LLMs. Uh, Transformers were originally introduced by Google Research and Google Brain in 2018. Um, and pretty much since then, we have seen these different advancements of the first breakthrough coming in 2021 with ChatGPT, and then the same architecture being slightly modified to be able to extend it to different modalities again in 2021 by Google Research itself. Um, and then the the advancements don't stop with these transformers. But essentially, what I want to show over here is I want to talk about shortly what are the core uh, mechanisms that make LLMs unique than the previous deep learning technologies that were present. Uh, so transformers are non-sequential. That means that they are able to interpret the input data that is given to them in a parallel sense, as compared to, say, the previous deep learning technologies like convolutional neural networks or recurrent neural networks, where the input data was streamed in a sequential fashion to them. Whereas with transformers within the LLMs, the model is able to interpret entire input text data or vision data in one go. Um, Transformers use something called positional embeddings to store information. Um, Positional embeddings make sure that even though the entire data that was given to it in a parallel fashion has some positional state context, it is able to identify a stream of like a sentence that's spoken. What was the first word within the sentence? What was the last word? What is the middle part? So it's able to preserve that state. And then the diagram that we are seeing here is called the attention mechanism, the transformer diagram, which uses the attention mechanism. We are going to look at the bottom 2 to 3 layers. Those are the most important aspects of this diagram, where you're providing inputs and outputs uh, together in two separate components via two sub-components of an architecture called encoder and a decoder. Uh, these inputs and outputs are converted into embeddings. Embeddings are just vector representations of words. Um, so, for example, an example of an embedding could be, we are here for the meetup today. This is a sentence. Um, and if I were to convert this into an embedding space of, say, n dimensions, and someone were to say that, okay, that guy is also here at the meetup today. So that sentence were to be converted to an embedding space. And if you compare these two embedding spaces, there would be certain similarities between these embeddings because they have some common words within those sentences. And essentially, we are going to apply um, these different transformer mechanism, attention mechanisms to the core concept of these similarity between uh, these embeddings. So the transformers use something called the attention mechanism. This is the core formula. What does this formula uh, denote? So QKV, Q stands for the query vector, key stands for the key vector, and V is the output vector. These are converted into the formula of softmax, and they give an attention weight. So simply put, it calculates the attention weight of query vector and key vector, which is called the attention weight, multiplies it with the output vector, V, and that essentially gives us an understanding of uh, where that vector would be in an embedding space. Multiple such words will have multiple such attention heads, and they will be merged together into something that's called multi-head attention, which is just dot product of these different attention vectors. So yeah, that's the core ideology behind the transformers. They have a couple of different steps as we go above in the diagram, but essentially we want to look at these bottom three layers, and we'll talk about how these core three bottom layers are modified for vision models. So when these models came out, they were really for text generation. But there's a modification that we do here that will enable us to use this same architecture for vision models. So in the vision transformers, what we are going to do is we are going to take an image and we are going to divide that image into, say, a grid of n by n pixels. In this example, I'm going to divide the image into 3 by 3 grid. Essentially, I have finally 9 different patches. I am going to arrange those patches into a sequential flattened format and then pass them through my attention mechanism. And that way, I will have a common vector embedding space, right? So this modification allows us to use different modalities together. And really, this is the core of Vision Transformers. The Vision Transformers paper came out in 2021. Yeah, so the key concepts are patching of image into patch embeddings and then converting them into position embeddings, which allows us a common vector space. Multimodal LLMs being able to do all of those common computations in a common vector space. Now we're going to talk about what are the different LLM OCR options. There's always going to be a race between open source software and closed source software. Closed source software is going to be slightly ahead. Open source software comes out of the box. It may not be always usable. You may need to go down the path of fine-tuning it on your specific data to make it perform better. So the barrier for adopting AI is becoming less and less as we go ahead, simply because the closed source models, they simply provide their models via an API. All you need to do is build your own workflow. You don't need to worry about the models. Just bring your own API key, plug it into your workflows, and you're good to go. Whereas with open source, you would require, you have these hard set hardware requirements with GPUs, where just to even load a specific large language model, you'd need at least 500 to 600 GB of GPU RAM. Closed source models are able to handle large contexts really well because they've been trained on their specific techniques, which are like a combination of the latest architectures. Large language models coming from closed sources are not fine-tunable. You cannot fine-tune them on your own specific data unless the LLM provider decides to give that as a service. So if your use case requires that you have a very niche area of data, you would want to choose open source models. Some examples of closed source and open source models: OpenAI, GPT-4o, Google Gemini, Anthropic, Mistral, um, and similarly for open source, Small Docklink, Lava, Blip2, Layout LM, and so on. I'd like to point out the Small Docklink in open source. This came out on, I think, Monday, and based on the academic benchmarks, it seems to show good, promising results, something to watch out for as we go ahead. How do we measure the performance of these LLMs? It comes down to accuracy. How do we extract the fields that we want to extract in OCR in a structured format, and whatever format, whatever fields we have extracted, what are the error rates at the alphabet level, at the character level, and at the overall word or field level. And of course, cost is always a factor. Based on the different surveys that have been conducted between open source and closed source, different surveys conducted between traditional versus LLM-based OCR. LLMs have shown to perform better with a lower character error rate. The product labels have 15% higher precision as compared to the workflows that involve OCR plus post-processing. Invoice understanding is better. Basically, everything is better. This chart shows an evaluation of accuracy on structured outputs extraction. So this is a comparison made between 9 different techniques. Out of these 9, so these 9 were not selected at random. These 9 come from different leaderboards, the top performing leaderboards, and then a company called Omni AI decided to do their own benchmarking. So these 9 models, techniques, these involve a mix of conventional, traditional OCR-based methods and LLM-based OCR methods. So out of these 9, I'd like to point out that only 2 of these, the number 5, AWS TextTrack, and the number 7, Google Document AI, only these 2 are traditional OCR methods. The rest of them are all LLM-based methods. We'll speak more about what are the limitations of these LLM-based OCR, but one significant point that has factored in this score for some of these 7 out of the 9 LLM-based OCR methods is that some of these are closed source models for LLM-based OCR. And these closed source models have their own privacy policies. So if you're trying to run your benchmark on, say, data that contains personally identifiable information, your model will just not work. The privacy policy will supersede identifying these PII included data, and they'll just fail. So what I think would have happened if the privacy policies were not in place is these 7 models out of the 9, they might have had even higher accuracy. All right, let's get into the challenges. Like I mentioned, LLMs at their core are next word token prediction models. They have their own attention mechanism, which is slightly stochastic in nature, which means the outputs that you get are not always deterministic. You might have noticed that if you ask something on ChatGPT multiple times, you may not always get the same structure or same output. The gist of it will be same, but you'll often always get different vocabulary or some different type of format. So that essentially is rooted in the fact that these are stochastic models, and if it does not have context of something, it may try to make up stuff. That's essentially what hallucination means. So that is still a challenge with OCR-based, LLM-based OCR, where it's possible that we are trying to identify some text. It's not present, and it's trying to fill up something based on its own internal biases or like unfairness that was there in its own training data distribution. So there's always the hallucination risk, the bias risk. And given that most of the LLM-based OCR are private or are like closed source, you would risk sending your private data to these models, to these giant big tech companies, which they might in turn down the line in a way use it to train their future models, which we don't want. So that's another challenge. There's a challenge of cost versus speed. Although LLM-based OCR are pretty cheap, these costs may compound when you try to build complex workflows involving multiple LLM calls within like a single step. When you introduce something called as agentic workflow, which we'll brief upon later, these costs may compound, and that's always a risk. Error handling with LLM-based OCR needs some additional steps where you need to establish your own confidence-based measures, where if the model is not sure what it's identifying, we could explicitly tell the model, prompt it in a way that, hey, if you don't know something, don't make stuff up, as simple as it is. And of course, you frame it in a prompt-friendly way. So yeah, it's possible to create tools around tracing these model footprints, the generation footprints. What are the industry use cases? These are really very common use cases. Finance, healthcare, legal, logistics, reading product labels to understand where a product is coming from, where it's going from. In legal, you can highlight key clauses within like deep-rooted fine print legal text documents. In healthcare, you can digitize the doctor notes or notes that have been scribed by like the different doctors and be able to make like go ahead from there. Automating invoice and receipt processing in finance is another major use case where you can read handwritten amounts, be able to understand, compile together different documents and infer the insights. Okay. What are agentic OCR use cases? Agent as a term in LLMs is going pretty hot right now. So let's define what an agent is. An agent is, simply put, an LLM which has access to certain specific tools, which it can autonomously call as and when needed. And the LLM will also make decision based on its own reasoning when to finish a specific call. So that's really what an agent is. You have user input coming into the LLM. LLM calls a function call, which is essentially a tool that the LLM has access to. It could be a web search tool. The LLM should be able to decide when to call web search. Or in this case, we're going to talk about the OCR tool. So LLM will decide when to use the OCR tool, be able to infer what is extracted, and reason in a better way to make a decision. We're going to see 3 examples of what the agentic OCR use cases look like today. So here is an example from Landing AI. They are doing document extraction using agentic workflows, where you have complex layout parsing the document, as you see in the image, is divided into subcomponents. You have a header, you have a table, you have some more sub tables below. So the model is able to exactly pinpoint with visual grounding what are the coordinates of those subcomponents within your image, within your OCR extracted data, so that we are able to build trust in our software systems, um, and be able to tell exactly what part of the extracted field is coming from which subcomponent of your document. You're able to verify your answers, and of course, this really helps with the human in the loop factor when we are dealing with LLMs, where you have a human verify whatever is extracted if it's actually legitimate. And yeah, we have the chat with document feature, which is the most common way, turns out right now, to interact with LLMs. So basically, you can chat with the LLM, ask it questions. It'll be able to extract and reason and answer in a user-friendly conversational way. This is an example of agentic document understanding, where you have a document, you're passing it through an agentic workflow. The agent will decide when and which part of the document to pick up using OCR, infer some things from whatever it has extracted, parse it down the line with some logic, some business logic that you have. If you are able to infer whatever you wanted in the first place, whatever your question was, if it's being correctly answered, then you can go ahead with it. If not, you have a validation agent in place, where if your feedback loop says that, hey, this is not enough to answer my question, it goes back in the workflow, and it tries to reason using its own capabilities and then extract whatever field was required. So you sort of have like a complex workflow using OCR at different places and be able to reason it. So this example shows the transcript that's between an officer taking notes and a suspect. So you have a data processing LLM, which will extract what the police officers are saying. And if there were any instances of potential misconduct, you have multiple outputs. You are able to merge those outputs, and then be able to understand whether was there any misconduct or no. If yes, then you can forward your answer. If not, it'll go back. It'll try to parse it in a way by splitting the document in a semantic format, extracting more using OCR, and then reason and understand the document better to answer your final query. The third one is browser use. I like this one the most, and I think this is going to get more traction as we go ahead. This involves automating the browser use using OCR and LLMs powering the OCR. Basically, what we are seeing here is an example of LLM automating the entire workflow of, say, grocery shopping in this case, where you are asking the agent, you're asking the LLM to go on that website, get me whatever grocery I want, and then the LLM will open the browser by itself, take a screenshot of the browser, automate their internal workflow of navigating the entire browser use, uh, look at the OCR extracted fields, whatever components, subcomponents it's interested in, and then make decisions based off of that. What are the future directions? I see that domain fine-tuning is going to be a very hot topic, simply because these large language models, these large vision models are very large. If you want an easy deployment strategy, or if you want more specialized models instead of more generalized models, you would want to bring down that entire large language model into a domain fine-tuned model, which will be a smaller sized, it'll have smaller number of parameters, and you'll be able to even self-host these kind of models. Agentic interactions is, of course, interesting because you can automate workflows using OCR-based LLMs, some of the examples that we saw right now. OCR inputs giving multimodal outputs from beyond text. What this means is while we have the hallucination risks, as long as we are able to mitigate the hallucination risks in a structured, in a reliable way, OCR using LLMs can also fill in the missing pieces with these context-aware reasoning methods, where right now, for example, Gemini is able to generate an image. So if I give Gemini, say, a 2x2 table or like any matrix, and I ask it to generate an image based on what should be the missing piece, it'll generate an image. So basically, it is generating a different modality. Right now, text is the most accepted way of dealing with LLMs, but as we see, Gemini is able to generate an image using OCR, reason, and then fill in that missing piece. And we of course need to have feedback loops within these OCR, the agentic workflows that we design. They need to have a human in the loop always until we reach a point where the reasoning is at a much more trusted level, where the hallucination risks are less. Until then, we need to have these feedback loops, which will continue to keep improving our workflows. Paperforms. Paperforms is Lean Innovation Lab's own starter kit for OCR with LLMs. It has a combination of traditional OCR with LLM-based OCR. You have different field validators. You have different rules, custom rules that you can put in. You have a sort of a document intelligence embedded into the workflow. It's a highly modular and scalable architecture. And you can also use these extracted fields using the traditional OCR to pass through a different correction mechanism, where you are trying to, say, normalize the extracted fields into a common format. Let's say I want to extract the country name, and I've extracted US, USA, and United States, and the different variations. So using these workflows, you're able to like normalize and have like a correction phase embedded in. Paperforms is going to be open source, and it's coming soon. So we invite you all to look forward to it and contribute to it. If anything, what are the key takeaways from this? Is traditional OCR as we know it, is it dead? No, it's not dead. There's still ways to go with the LLM-based OCR. That doesn't mean that the current agentic use cases that we see today are not in any way a unique approach to the integration of LLMs with software. So we are able to get higher accuracy on different problems, on really hard problems, like be able to extract summaries from really large OCR extracted text. And we are able to get structured text in one single step. All right, that is about OCR extraction with LLMs. And I'd be happy to take any questions. Yes.
So one of the things you mentioned earlier on with traditional OCR versus was the issue of content, right? Zero versus O.
Right.
How do the LLMs work on something like that? Like if there's a alphanumeric version, especially if these are anybody.
Right. Sure. Okay. So the question was, I'm going to switch over the slide as well to that. Uh, right. So no understanding of context confuses LLMs are able to skip this error that traditional OCR makes, where it confuses zeros with O's and O's with zeros. So the way this works is with traditional OCR, these are trained on conventional methods like convolutional neural networks or recurrent neural networks, where the data interpreted in the input is part of each pixel at the pixel level. Whereas with transformers architecture that backs these LLM-based OCR, uh, they are interpreted in a fashion which makes sure that the input has positional embedding context. So it makes sure that the context is not lost while converting them into a common vector space, which is something that the conventional methods are really bad at. So for example, um, they the recurrent neural networks, which are really used for the traditional OCR problems at the highest level. Um, they have a problem that's called vanishing gradient, where as you pass down the deep learning workflow, the deep learning model, different layers, as you pass through these different model layers of the model, um, the gradient that actually collects the context it decreases diminishingly. And finally, it's such a small value that it doesn't have any information of what's before it, what's after it, which is really something that the LLMs are able to solve.
So like, it's like you said, LLM is predicting, right? Like it's predicting the next token.
Yeah.
And something like an alphanumeric where you have, you may very well have O's and zeros mixed in the same string.
Right.
You've seen it does a good job at that?
It does. So the training distribution data of these models is so large. For example, when ChatGPT first came out in 2021, they claimed that it was trained on the entire internet. And how many examples do we have on the internet where these examples, even though they may seem to us, might not come often, but if you have the scope of the entire web as your input data, it is able to derive, like, have those learned representations in its distribution that it's able to distinguish.
Thank you.
So you mentioned about the agentic AI, right? Running
Yeah.
in the local. So does it connect to the LLM on the cloud, or is something local on their machines or something like that?
So yeah, the question was, just to repeat the question, I'm going to switch over to the slide again. Agentic OCR use cases. So the question was, the agent that we design in our software workflow, is it something that we have on premise within the same server that the LLM is hosted on, or whether it's on the cloud? So really that depends on the software architecture of the workflow. For example, for closed source models, we really interact with the model via an API. So in that case, it would be wherever your software resides, the agent would reside in that specific space. But if you are self-hosting a model, you would be able to have those agentic workflows within the same place where your model resides. To expand upon that, there's a new concept in town, which is called MCP. MCP stands for Model Context Protocol. So this is a new data protocol that came out, I think, February. It's very recent, last month, where your tools that you're seeing in this diagram, the function calls, these function calls need not reside even within your software architects, even within the place where your software resides. It can be somewhere else. So basically, I can create a tool to, say, research some specific workflow that I want, and I can publish that on a separate server. And the model will be able to interact the model will have its own agentic space, but it will be able to access that specific tool, which is outside of its software space. And that's really what Model Context Protocol is. And it has really good different use cases where people have their own tools written in, and you can switch the client, but your core idea that the tool that's going to work on, that still remain the same.
But in the context of that browser, right, where you show,
Yeah.
so that in that case, it's like an plugin on the browser, or like how the agent is running on that.
So in that case, it's a plugin that's residing in the same space that the agent will reside in. One example of that specific browser use is an agentic workflow that came out about 2 weeks ago by a Chinese startup called Manus AI. I had a fun interaction with the CEO of Manus AI, where I asked, okay, so looks like you're doing a lot of OCR, extracting, sort of doing the research part of it, but how do you comply with the privacy policies of websites that do not allow scraping? He responded saying that, oh, we use this browser use. And that's how I found it, and I decided to put it in.
If you want to take what you showed, like in actual production environment where either ML ops or LLM ops, so like over a period of time where thousands and thousands of documents are coming in, over a period of time where performance may degrade and you'll have problems of stagnation or something. In that case, how do you compare, like, because you said you cannot fine tune the closed source, right? But at that stage you probably may need to fine tune, or because if your performance is
right.
So how do you then
Yeah, to repeat the question, how do you handle data drift, or in this case, model drift? So model drift is when the selected model that you have was trained on one specific task, but down the line you have deployed it, and say 5 years down the line, the input data, the type of input data that's coming is different from what you initially designed your software workflow to handle using these LLMs. So how do you handle these cases? So I think like all softwares, especially with integrating LLMs and these vision language models into the software workflows, it's important at this stage to have your monitoring workflows, your traceability workflows set in, and always as a best practice, it's a good idea to separate your LLM integration layer from the rest of your software, so that if you notice any model drift or data drift, you're able to completely plug that out and plug in a separate model which works for you.
Good evening, everyone. So my talk is going to be slightly less technical. Thanks, Amit, for the talk, and thanks to Solution Street for giving us opportunity to share. So I'm going to talk a little bit about all the challenges or the battle scars we have, or the things that we learned the bad way, or kind of the good insights, etc. So that I hope by the end of this talk, all of you can take something out of it and don't repeat the same mistakes what we did. So kind of a lot of what I'm going to share is based on a lot of work that we had done in the last 1.5, 2 years of kind of productionizing these AI workloads. Quick intro of myself. My name is Suresh Taluri. I'm the founder and CEO for Lean Innovation Labs. We do a lot of product development and consulting services based out in Reston, both in federal and commercial space. Lately, our team been helping a lot on with our clients' journey of taking from idea to productionizing their AI workloads, all the way from strategy to execution, etc. I want to start with some of the example AI workloads that we have done. More in general, I classified a lot of these based on various types of use cases that we are solving, various tools and techniques that we're using. Let me start the first one with the generative AI side of it. A lot of what we had done is primarily more on the code and configuration side. We have built this no-code platform called FlowScript. Essentially takes your application requirements in a plain text format, written in a business requirement documents, uses LLM as a compiler, and then just spits out a bunch of configuration and code out of it. So primarily letting you to write your application requirements in plain English and have a fully functional web application. So just the challenges as part of this journey tend to be mostly like in the kind of, we're using a lot of few short prompting, a lot of prompt engineering. We kind of started this journey back when 3.5 was the hottest. So a lot of the challenges we were facing is having the predictable response in a repeatable way, essentially, that you kind of have a functioning application out of the code and configuration that is generated. And also like suddenly the latency is a big issue because we are kind of feeding in 5 to 10 pages of your requirements, and we need to kind of generate a prompt large enough to give the whole object relational model of your application, kind of fit it and make sure it's interpreting the right way. And even cross-referencing, like for example, I'm talking about a certain page in the application or certain table in the application, it kind of hits the right intent there. So that's what one of the big area of challenges for us. The second area of work that we've been doing on is more on building a support chatbot that is embedded into an existing SaaS application. So we're working with one of the clients who are essentially dealing with a lot of sales and revenue operations for Fortune 500 companies. They help in organizing the sales teams and manage them. They have a fairly complex way of doing all of this. So we're working with them to build an embedded chatbot that sits right within their application, understanding the user context and kind of providing that contextual help to the user. So a lot of, since they're dealing with sales data, there's a lot of sensitivity around the data that you can use and send it to something like an OpenAI or any of these big models. So we had to do with a lot of data anonymization, kind of making sure like we're not leaking any privacy information, kind of process it locally, and also identifying their custom entities, like when they call an account, when they call like a sales team person, kind of doing that at a velocity so that you're not really compromising the performance of your chatbot. So we had a lot of data sensitivity and data privacy sort of issues that we were handling there. The third one also highlighting here is more of building an assistance. Primarily, we're doing this for one of our insurance customer. Our journey is more of helping this insurance client to build a claims assistant. So claims, like in general, like if something happened to your car, something happened in your house, you're filing a claim. That typically tends to be a very lengthy process involving a lot of different content coming from various documents, what the customer said, etc. So this was a very unique experience on like not just building a chatbot, building a user interface that can fit into the existing workflow of all these various players, all the way from the customer reporting their loss for the first time. How do you provide that experience to the customer so that it doesn't really look like an annoying chatbot or kind of taking them away from what they're used to or their comfort zone, and also helping the claims adjuster dealing with all this complex process that they're doing most of those manually or some system automated stuff. And also we did a bunch of work around the workflows. So essentially more coming to the realm of the agentic workflows. Essentially one of the big challenge over here is identifying the intent of the user. And once you identify the intent, then kind of also identifying what they're talking about. I might say like just my name Suresh or just spelled it wrongly, or there might be 4 or 5 people with the same name. So there's a lot of work that typically goes in. You identify the intent, you extract all the entities out of what the users are specifying, and then translate into really the entities that are in your system, essentially, kind of providing the transformation rate. And again, you need to do that at a very high speed, so that it doesn't look like, hey, I'm going to take 20 to 30 seconds to respond a simple task for me. So there's a lot of challenges around that. And the next space that we did some work is on more on the data analytics. We do a lot of we help our customers a lot on the data side, building data lakes, helping them to move their data, etc. So we were doing few use cases here, more of starting from very simple descriptive type of analytics, where you ask a simple question, hey, what is my sales for this year, or how much did I spend on my AWS last month? Two, now we're kind of exploring more of a complex use cases where we want to do more like a deep research sort of techniques, essentially kind of split your whole analysis into multiple steps, do these various analysis, kind of start relating to each other, and then provide this comprehensive report so that the end user can look at it and understand. So not just like at the spur of the moment based on the question that you're asking, or more in-depth detailed analysis of that. That's also pretty fascinating on how those things are evolving and some of the work that we could do. The last one is a little bit what Sumit covered more on the automation side. We're helping some of the customers kind of automating their manual process of taking these sheets of paper, entering into the system one by one record, like 700 cards. They're trying to enter it manually. So those kind of use cases. But one of the challenge over here is like we are dealing with a federal customer. So obviously, I can't just go and use OpenAI, or I can't go to Azure OpenAI and use it. So everything kind of comes with its own ADO process, making sure you're using within the AWS Cloud, what models are exposed is very different from what is there on the commercial side, and also going through the whole legal and compliance sort of issues around that. So it's obviously, you can't move at the speed at which you're doing on the commercial side, but certainly for good reasons, you need to go through that red tape to get to the solution. So a lot of what I'm going to share here is based on these kind of workloads that we had done over the time. So let me step back and say why productionizing AI apps is hard, right? I'm sure by now most of you guys have done a prototype or something kind of showing like how to use AI and get it out there. But personally, I feel like having something that delivers a value consistently. It may not be changing the world like what everyone promises over something simple, consistently, and reliably. It takes a lot of work for that. Kind of obviously, there are multiple reasons. I try to kind of classify these in these 5 buckets. Certainly, a little bit what Sumit also covered before is one of the biggest issue I see is the non-deterministic nature of the AI in general, right? So it's not like a traditional application. I built a screen, I clicked on a button, it's saved in the database, I verified it, I can do it 1,000 times, trillion times, it will be the same thing. So you are dealing with this unpredictability, so you have to build your user experience, your you kind of error handling, you kind of you debugging, you kind of auditing and everything around this. So you need to really kind of think with a different mindset that it may not work 100%. And you need to build things on the top of it. The second one also often sees like providing these suboptimal user experiences. I know everyone is comfortable with chat. The first thing comes with AI is chat. But often a lot of the things that we do is doesn't really work with the chat interface. Because again, from the user interface perspective, what it provides, everything you have to type it, and often you can go wrong with the model side, and then you kind of doing that back and forth versus something more of user interface driven, where you can force the user way to click what to do, etc. And obviously, I feel like this is one of the area you kind of see a lot of innovation happening. It's constantly evolving. I don't think we are there yet to understand exactly how we're going to interface with the AI, but obviously you can see that the patterns evolving. So again, like this is something new. It's not like tested and every user knows how to use it, where you can just build fast. So you need to really put some significant part on where do I want to introduce the AI experience in the user flow, essentially, so that it feels magical and kind of but equally it shouldn't feel like, hey, something I'm dealing with a bot in my face, essentially. So obviously the third aspect I see is like a lot of the development and deployment related challenges. Obviously, as a developers, we are tuned to build in certain way, but obviously you need a different sort of mindset building these AI apps. and you kind of now constantly think about, I make one OpenAI call, it probably takes maybe the best case scenario is like 2 seconds or 3 seconds. The more complex it gets, it can be like 10 seconds. Now I'm doing 4 or 5 of them easily. It's going to take 1 minute. So you have to constantly think about how do I optimize it without compromising the consistency or the quality of the response. Obviously, the cost is another big factor. Slightly, it's getting better from where it was last year, but still, it's a challenge. And obviously, we're constantly bombarded with new tools and techniques and new frameworks. How do you keep up to them and still have something that is working and consistently replicate across the dev team, and everyone moves towards some delivery here? I also feel like the trust and safety concerns are also one of the bigger reason why this makes hard. It's easy to build a chatbot and provide a response, right? But really, like demonstrating what are the sources you used, which part of the document you used, or somebody suspicious of what it's delivered, they should be able to easily dive in and provide the transparency to them. That takes a significant amount of effort, both from the backend infrastructure or even in the UI side, actually, and really thinking through all of it, because obviously you can't expose everything, but the more you make it a closed box, you have these trust issues. And obviously you have a lot of safety concerns, like, I mean, you're kind of using bad data, bad prompting, kind of prompt injections, kind of all the scenarios that you need to handle, because yeah, it can potentially do whatever it needs to do without the proper guardrails in place, essentially. So the fifth one is also fine. It's very critical. Like often we tend to overhype the solution and kind of oversell it without providing the really significant value. So also like how you pitch your solution, focus on something simple, something that you can deliver consistently and that you can back up with the facts, the traceability and everything is also going to be a very key factor. And this is what all the factors that you need to work towards to get to something into production. Let's start with the non-deterministic nature of LLM and how do you do that, right? We are probably familiar with this diagram here. You have an input, you kind of your instructions or prompt, whatever you call it. You're giving it to an LLM and LLM is producing an output, right? I call this as the Gen AI processing unit, a very, very foundational level. I mean, you have all these flavors of agents, multi-agents, the RAGs, and all those various techniques that you're building on the top. But if you take out all the noise at the bottom, what you're doing is essentially doing these kind of processing units. You're giving an input, instructions to an LLM, generating an output. So obviously, if you look at this picture, input is something dynamic, either coming from the user or from a document or whatever it is. Instructions is what you have the control. Obviously, this is where you need to put a lot of effort in making sure you're giving the right instructions. Again, that can be like augmenting with the right context, history of what happened to the user, what they're doing, etc. And obviously, you can control the LLM, and obviously they provide some parameters to tweak it and tune it. But the output, if you see, that's a dotted line, no matter what. Obviously, some of these workloads are getting much better where you can provide this consistent output with a greater confidence, but end of the day, there's a dotted line there. And often you see that a lot of these solutions that you're building is like a kind of, hey, first I'll extract it, then I'll summarize it, and then I'll kind of give it to the LLM to extract certain things. Then I'll make it to call the function calling with an over API, all of that, right? You're doing multiple steps. Obviously, now your whole pipeline is a lot more complex. I mean, a lot more multiple steps involved. So anyway, if you think of the probability of no errors in the first step, let's say it's 0.95 0.95, and the second step is 0.97, the third step is 0.98. So end of the day, you're going to end up with a model with a solution that is only 90% accurate. So not that looping is bad or you can't use it. There are a lot of use cases where you want to do that a complex problem, you want to split into multiple and then use it, but something to keep in mind always, actually. Reduce it as much as possible. Reduce, like I've seen a lot of times, like even in our development process, like something that you can do with a traditional approach or something maybe you can kind of tag it and store it in the database. Rather than doing that, you kind of generate the tags dynamically every time you have to interact, right? You do these kind of unnecessary steps just because LLM can do, doesn't mean that you want to do it. And just making sure that you are reducing these processing units as much as possible is going to be a big factor in overall accuracy. That's also kind of something to keep in mind as you're developing these solutions. So how many of you have heard about evals? Good. So this is one of the foundational element for you to really build and deploy anything into production. Evals are like kind of a way of measuring the accuracy, or measuring your model performance or your AI application performance to understand how accurate or what's the quality of it or how reliable it is. Pretty much you can tweak it to any metric that you want or how much value you're generating with the customer. It's in a simplified terms, it's pretty much like the test case driven development. You build a bunch of test cases, just like in a regular application. With the AI apps, it becomes like 10 times more critical, or maybe even more essentially. Without having proper evals in place, you are just driving your solution with your gut reaction. I tried these 4-5 prompts. Okay, good, let's push it out, right? Without these evals, you don't have any way to qualitatively or even quantitatively measure your performance or kind of how well your solution is doing and keep improving over the time. So it shouldn't be like, hey, I just released a new version of it. It's using the latest O3 model or GPT 4.5 model or Anthropic or so one of this model, right? So what does it even mean actually? It's good. You got the latest model. So what does it mean? So your solution has to be around like, hey, ran my evals, I improved by 1% by using this model, by tweaking this. Because without that, there's no reason of just changing the things, because you're kind of chasing your tails if you kind of do without the proper evals in place, essentially. So I can't again emphasize the importance of it. Again, it doesn't need to be super complex system. You can start with a simple Excel. You can start with some human generated evals and also use some synthetic evals. Again, like obviously, this is where it takes a lot of time to get the process going, but it's very important. It's not a day-to-day activity. Let me release something and then I'll work on that. I know we all reach the test-driven development, but rarely we follow it. But in AI apps, I feel like that gets even more and more critical. Again, all of these evals, they need to be tailored to your application. Don't do out-of-the-box evals. Like, I mean, obviously they can give you some jump start, your reference scores, precision, recall, and all of those. But all of those metrics without the context of your application are somewhat meaningless. So human in the loop is very important. Involve a domain expert. You might get the 95% accuracy, but you see that at least 1 or 2 evals are kind of constantly failing. Having somebody review that manually goes a long way, because they know, hey, that's because you're not looking at the right index for your documents, or you kind of not considering this scenario on how it happens in our business, right? So it's very important to involve humans also in there. Don't again forget the value-driven KPIs. It's good to have all the MRR, F1 scores, and all of these metrics, but it's very important to end of the day measure, is my customer satisfaction improving, or am I reducing the amount of time that is spent by a claims adjuster to process a claim? So do make sure you have some KPIs around that. Again, look for both qualitative and quantitative. Qualitative is more of like you can even again use LLM to say, hey, does it have the right tone, or messages being too rude, or we're not helping the customer. Again, quantitative being very metrics driven. You can automate it. You can easily to measure how you're changing it over the time. Some few more other tricks to kind of reduce the non-deterministic nature, grounding the model and tools. I'm sure everyone, most of you guys heard about the RAG for this. This is how you ground contain what is generated for the output. Similarly, API calls. A lot of these models are also getting good with making function calls. kind of injecting the context in the right way based on what the user is asking. So utilizing the knowledge graph, so that way that's also seems to be gaining a lot of traction, so that you can easily relate when I'm talking about context of particular user, what kind of products they have in our solution, etc. You kind of can provide the relationship and kind of make it more relatable for the model to understand. Again, you can do the fine tuning with the domain specific data. Again, don't chase it unless it's really needed. So enforcing the structure outputs, that's also a very common technique of making sure whatever output that is generated, I mean, not for every use case, or for like content generation, etc. This may not apply, but your workflows, your automation, etc. Make sure you enforce the structured output so that you can validate whatever the model is spitting it out for you. And if something is wrong, then you can do a retry or a kind of a multiple tries, but you can clearly articulate, hey, to the LLM, how exactly you want your output to be. Yeah, again, using like formatted responses, validators like Palantir, this goes a long way, and add retry loops like what I was mentioning here. And again, I know we all love using AI, but don't overuse it. That should be really your last resort of solving that. I mean, obviously, AI provides you that the magic part of our solution, but just because you have it, don't try to use it again. Going back to my previous slide, again, anytime you use it, that adds certain level of unpredictability to your solution, and that will overall denigrate your accuracy. So the next part is the user experience. Rethink the user experience. What I mean by that is like, I mean, just quoting one of the example that we'll do, going back to the claims experience that we were talking, I was talking initially. Our first gut reaction, hey, let's build a chat interface so you can keep telling what happened to your event, and then we'll keep asking these questions. We did that. And then we realized like, this is probably a lot more annoying than filling a form actually, because you kept on going asking, hey, I missed this. Hey, can you give me the address? Oh, do you mean by this in Fairfax? Like, I mean, that's kind of not always easy. But what the problem we're also trying to solve is like the existing claims form, when they fill it, what they're doing, the way it was done is like asking like 20 different questions. And at the end, they ask like, hey, free form notes, like tell us what happened in the incident, right? So what we did is like, rather than doing all of this, we flipped it. So we took the notes part of it to the front, and we gave the free form for the users to express, particularly when they're in a stressful situation, right? Something bad happened to them, right? So it's very easy for humans for us to vent out exactly. I was driving here, somebody came and then hit from the back. I was not going above a certain limit. I was driving my this car, blah, 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 right? So what we did is essentially took the text and then filled out the form for them, rather than forcing it as a last step, because by the time they fill out all the forms, like no one is going to write more than that. Like it's like always skip that part. So it's a very simple trick of putting this AI in the right place. And then we also gave an option like, hey, I don't want to use AI, then they can always go to the regular form there. So that was very seamless user experience there essentially. So that's what I mean by like start with the user experience, start with the value that you want to provide, not with I'm using AI, I'm going to do this so and so technology or tool here. So that's very important, I feel like, to do that. So controlling the uncertainty, kind of baking this into the user experience is also going to be very important. For example, your conversation is going out of hand there. Provide a way to make sure you provide some guardrails and provide a way for them to call a number or raise a support ticket. And that's kind of one of the things that one of our customers was adopting here. So it's important to bake into the user experience there. Ensure transparency kind of fits into one of the trust thing that I was talking about. It's not just always about your answer or how amazingly you did it. You might be solving within 5 seconds, but if the trust factor is not there, they may not use it the next time, right? So it's very important to kind of somehow translate what you did and how you did to the users. Building guardrails. So kind of, again, I was talking about the user experience perspective. Keeping human in the loop. I'm sure a lot of you guys already experienced this. And also this one more thing, communicate the limitations. So it's like, very often, like again, we try to boast this chatbot or any of this, but we provide as something that can solve every problem that you have. So make sure that you're upfront communicating that clearly rather than spending like 10 minutes and figuring it out. You need to talk to somebody on the call to complete that. So again, certainly give a lot of importance and guide the users. Like, I mean, it's very simple to do, simple instructions, simple kind of, sometimes if it's not going the right way, you want them to launch a form, provide that link in the chat, kind of make it easy for them to visually see what's going on, what they did so far. There are a lot of these different ways that you can do this. Switching the gears a little bit more from the developer side, one of the common mistakes I see is like everyone is so much focused on the tools. Hey, there's a new agentic framework out there. Hey, there's a new model out there. Let's try this. Hey, this seems to be a lot more cost effective. Now let's try it, right? So much noise, constantly bombarded all the time. It's very, very important for you to kind of ground it to the fundamental value that you're trying to deliver with your application, essentially. So don't get distracted with some of the examples. Hey, I have a RAG problem. Like, hey, I'm not getting the right answers. Let's use a new vector database. Let's throw the Postgres and all indexing, whatever it did. Let's use Pinecone, right? Take a break, take a deep breath, see what's wrong. Are you kind of indexing wrongly, wrong content? Once you really show that the database is the problem, then move it. Again, accuracy issues. Hey, it's not exactly working right what I want. Let me try the new model that OpenAI released. Again, there's another scenario like the agentic framework that we were using is not working. Let's switch to a new shiny one. And sometimes the other problem, like this is too simple. I need to kind of let's fine tune the model, like and make this like a lot more complex than what it needs to be, right? Rather than focusing your energy on making sure like you're measuring your accuracy, you kind of providing that dependable solution. You kind of start deviating. Hey, I'm done with this. It's already working. Let's just focus on like more refining this further, more trying a bunch of other models in there. So again, not to discourage there, certainly invent, but stay focused on the fundamentals there. So this is also the common thing I see is like be aware of the too many abstraction layers. I know we all use these frameworks like Palantir AI, or LangChain, or Crew AI, and whatever Swarm, OpenAI Swarm, and all these things, right? End of the day, these are all some sort of fall wrappers, and not that they don't provide the value. That's very important to see what's going on under the hood. If you don't pay attention to that, it's just a matter of time you'll hit the brick wall there. It works, but I don't know what to do beyond this. And then you try to chase the next abstraction layer after that. Personally, I'm not a big fan of the shiny IDEs or drag and drop stuff. The reason is like, I'm sure there'll be a place and time for us to use all of this. But right now, in general, this is evolving so fast. You can get something quickly with these IDEs and drag and drop tools, but it's important for you to understand exactly how you achieved what you achieved. Otherwise, again, going back to the previous point of view, hit the dead end pretty quickly. And don't forget the latency, cost, and complexity early on and factoring in every development process. We had this nice fancy evals of 100 or 200 that we built for one of the product. And every time you run this eval set, we're getting a bill of $50 from OpenAI. And we integrated nicely into our CI/CD process. So be aware of these pitfalls. I mean, not that it's not important, right? I mean, you need to still balance it. And obviously, things are getting cheaper, but make sure you kind of factoring this early on. And some of the common misconceptions also want to cover here. I was talking about it works fine. I have a strong gut feeling. Let's move on. So stay away from that. This is another favorite of mine. Users will tell us when it's not working. I provide this thumbs up, thumbs down. I know when my stuff is not working, I will get a lot of thumbs up, right? They are not going to. So it's important to monitor what's going in and what's going out and have your own mechanism of evaluating it. So this is the other thing, like common of, hey, we tried it. AI is just not there. Hey, this AI is not smart enough. This is just hype. It doesn't work. I get that. Again, I don't say that there's no hype there, but put your energy in understanding what you did, how you did, and energy in optimizing it and improving it and enhancing it. And then probably you might have to give up. But if you start with an attitude like, hey, it's just the AI's problem, not my problem, then you're going to, again, hit the dead end pretty quickly. So one more thing is like we as an engineer stop all these metrics, keep watching it. Hey, our score improved by 95%, 97%, blah, 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 right? But we forget to get this support person who was really fielding all these questions from the customers for the last 5 years or 10 years, right? Don't miss them. It's very important to make them as part of the loop because they can see this one particular question, which is probably the most buy or deny sort of a decision for the customer. Make sure they are having their opinion in here. Again, we tend to have the more complex solutions, the better chances it will work. I use this more multi agent and kind of with the function calling, and then you can work all these magics. But is it working 98% delivering the small values more important for me a lot of times than 70% works, but it does more complex. Again, I'm not saying that there's no fit for these scenarios too, but make the call appropriately. This is another common thing. I did my POs in a way how hard it can be, right? This is where I feel like fundamentally taking something to the production that delivers the value with consistency takes a lot more hard work than just making an OpenAI call. So probably the one of the slide deck a lot of you might have seen more in the ML world. The actual ML code is really that tiny black piece. This is very similarly you can apply to developing the AI apps. A lot of the work, hard work that you need to do is getting the data, tuning your prompts, making sure you're auditing everything, you're tracking what's going on and kind of iterating it and improving it constantly. The final AI call might be just a few lines in this huge code base that you built. Coming to the security and compliance, guardrails is one of the best way to stop. Still not that it will guarantee you 100%. Again, guardrails on your data quality and pre-processing. And again, I think we talked a little bit on this already here. So provide access controls. So this is also one more. Initially, some of the products, what we're doing is like directly querying the database and trying to get the query and everything, right? So which is good, gives you a lot of freedom, but end of the day, you kind of skipping out of the security layer when you do that. So kind of think of like maybe better to go via your API layer, which has already the baked in security. If I'm a user coming in and asking a question, maybe you don't have the permissions to get all the account information, right? So a lot of the stuff you already have it in your API layer. Obviously, you have to see the right trade-off there because you're kind of somewhat constrained to the freedom that you get. But for one of our customers, that was very important. They don't want to expose the whole database because that's very risky for them. So tap into the APIs. That can also be a very good guardrail for you. And you always make sure you enforce your ethical and legal guardrails. And again, like this is just probably a few of the areas that you can imply. Pretty much you need to think of end-to-end what can go wrong and make sure you have some answer or some way of protection for that. Again, involve your legal team from start because you make a lot of assumptions as a developer that I can do this, I can create the table, I can treat all the users as the same thing, but making sure that you are involving them. Otherwise, you spend a couple of months and see that, hey, you can't use AI because customer has this clause in your contract. So make sure you're kind of involving your legal team also early on. Yeah, again, like, so what I mean by this, be prepared to customize your AI experiences. Like this, one of the things we had to do for one of our customers, like they have this multi-tenant setup. I mean, a lot of customers using their SaaS platform. And each customer of theirs has different feeling about AI. Some of them are very like, hey, I never want to use it. I don't want to even have that AI term anywhere. Or you need to sign this agreement with them. Some of them are very liberal. Hey, let's try it out, right? In a way, you want to bake that flexibility in your solution so that you can turn these walls on and off based on your tenant, essentially. Feature flags are also a great way. You release this into the production and something bad or terrible you noticed, make sure you have some feature flags there to quickly disable it or control it. Sorry. Control the damage it can do. Traceability and audit trail. So everything you do, make sure you have the trace logging, either using LangChain or Logfire or any of these tools or your own custom built stuff. Make sure you know exactly what's going to the LLM, what's coming from the LLM. Make sure, obviously, you might be sending some sensitive information. Make sure you're masking that or protecting your logs, etc. Certainly, this is going to be your best friend for sure. So these are another thing I want to say, like, don't start with, I'm going to use AI to do so and so. Start with like, I could onboard the new user 2x faster, or I can reduce my claims processing by from 2 days, or I could build this complex application just by myself within few hours. So start with those kind of statements as your mission and build from there. Clearly articulate the expectation. Kind of see like one of the example I see like for our no-code platform, one of the user asking like, hey, build me a Web3 Texas Hold'em multiplayer with crypto as chips. So you kind of see like how we didn't really exactly set the expectation, what they are kind of hoping our platform will do. So be clearly articulate that. Again, it's a tool. Don't take it as the solution for everything. Use it wisely and get the right stakeholders early on. So end of the day, it's not about just you realizing the value, making sure you are kind of pushing your understanding's value from the right stakeholders perspective. And also they are the ones who's championing it for you. You can say, hey, I built this amazing thing with the AI, et cetera, et cetera. For the end user's perspective, it doesn't mean really anything. They need to see that, and whoever is dealing with them, you need to make sure they're on board with this. So that's pretty much it. More of the tips and tricks. So I guess like I just want to showcase some of our open source contributions. We have recently released opsloom.io, an open source blueprint for a lot of the work that we are doing, and that's what we're going to continuously improve and push out there. Feel free to check out. Sumit mentioned about paper forms. FlowScript also is something that we're planning to release our compiler version of that to the open source. So again, would allow you guys try it out and like it or give us a feedback or contribute to hear from you guys. That's pretty much it. It's again, thanks for the opportunity. And I guess again, I know a lot of what I shared here is based on our experience trying to solve these customer problems that we're dealing with. I'm sure these things are constantly evolving and changing. I mean, I'd love to hear from you guys. Thank you.
Questions? Do you see LLMs getting used in ETL pipelines, like where, for example, you have cleaning, pruning, transformation?
Yeah.
Or because you mentioned the danger is non-deterministic nature,
Yeah,
right?
exactly.
So if I processed a set of data and went to table, next time it went to some. So how do you see that flow?
Yeah, no, it's a good question. Like for one of our customer, we use Databricks heavily.
Okay.
So we do a lot of these pipelines and kind of moving the data around. I see like Databricks is trying to push it to a certain way. So the way I see is like you need to be very careful on how you build a solution. If you're trying to say like, hey, I can build an ETL pipeline that will move data from my Salesforce to my XYZ system and then do that, I feel like that's a pipe dream. But let's say if you have these 1 or 2 tables that you clearly articulate the schema, clearly specify the metadata, clearly define the relationships, then you kind of start building the simple solutions on top of it. So you need to put that significant amount of effort in defining your schema, making sure the data is clean and clearly articulating the relationships and kind of giving all of this in the right way to the prompt. Then you can think of building some simple solutions, because some of our text to SQL, that's what we did. We had good success with few tables, some simple complexity, but the moment kind of giving with a wide data set without with ambiguity, then we cannot see like, particularly the data, right? You don't want to take any submit a report like I generated $1 million where you generated just $100,000.
So I was actually gonna ask a similar question, because I've been, thinking about for a while is, using an LLM or something like that to predict the transformation.
Yeah.
Right, of essentially saying like, I wanna set this loose on my database with all my tables, and I wanna say, this is what I want it to look like.
Yeah,
This is
exactly.
what names are gonna look like, this is what this is gonna look like. Tell me what the transformation should be, so I don't have to go and have somebody go through.
Yeah.
I work on the government side, right? You have thousands of tables with millions of columns.
Yeah,
If you want to have a person or a team go through and like do that manually, it's a crazy long process,
Yeah.
right?
yeah,
So I've been trying to think of like, how can you use that, using all to predict those transformations when you have a set schema you want to get to, right? Because you can
Yeah.
essentially go and say like, predict my transformation. Okay, now do this transformation. Does it match what I'm expecting it to be?
Yeah.
Yes or no?
Yeah.
Um,
No, those are all like, yes, I feel like those are all fascinating, good examples. I mean, a little bit what I can tell from our experiences, like we did a little bit, few of these versions of this with the flow script or no code. We kind of essentially generate the whole table schema structure based on what the user specified, kind of identifying the tables, what column should be there, how should you should be joining, all of that stuff. And also like some of our reporting that we're doing, we kind of do the similar things. I feel like again, kind of a little bit leaning to what I'm saying. I don't think it's there at like where you can take away the human in the loop. It can be more like a good co-pilot for the user, so that I'm not handwriting all the schemas or building the structure, I mean the complex SQL, etc. And anyway, that's what I see with a lot of these tools. So that can be more of your AI can be your co-pilot in that scenario, but it's not like an autopilot for sure.
Yeah.
And
Yeah, we have the similar problem with like, we load data from Excel.
Yeah.
File. Sometimes we define it like a length, character, or, is an integer. Sometimes the data they load, it's a huge data.
yeah,
They have a couple of columns, they just, messed up. So it caused the whole thing fail. So if we have some like AI can clean up the data.
yeah, no, definitely. So
Yeah.
that's a good use case scenario. Like what you can always think of is like, yeah, it's certainly good at pointing you the errors, right? Maybe the false negatives, but at least you can use AI to identify all the negatives. By that, I mean like all the rows which are like bad, or can let the AI kind of determine that for you. And then you can say like out of millions of rows, you kind of filter like, hey, you have this 100, which might be potentially wrong. Then you can have at least reduce your amount of workload there basically. Because if everything goes through the right structure, more of data types and everything goes into the table, that's fine. But at least you can add one layer before you load into your table using an LLM to scan your results, identify these bad ones, and maybe 95% of them are bad. Maybe a few of them are good, but still it flagged as bad. You can easily use for something like that.
When you look at the news cycle, right, despite that, general artificial intelligence is coming, and when you think about it, not all even the human brain has specific neurons. So when you put it in, as you mentioned, in business application, right, you need specific things. So
Yeah.
what do you think they are saying? What is general artificial? Right? How can it work in a business?
No, so I mean, maybe it's a very loaded question. So I'll try to give my answer more from the practical applicability, right? So that the notion that there is AGI and it can solve everything without, I feel like you can probably bring Einstein into the room and he can't answer unless you tell him clearly exactly what you're dealing with and how you kind of want him to solve, right? So that's where I feel like you can have AGI, but still there is going to be a good amount of effort that needs to be done to provide the context, to provide the instructions. Then you can use the AGI maybe. Still feel like I don't think we're anywhere close, but at least right now I wouldn't plan or building anything assuming that there's an AGI for sure.
Yeah.